Welcome back, pre-calc students, to day 5 of Unit 2. More inequalities, but today they are rational inequalities. What we did yesterday, day 4, was absolute value inequalities and quadratics. The great thing about this new one is, again, the same strategy with the plus-minus line, the intervals. The only difference, just like between the other two, is how we obtain the partition numbers. So we have some steps here, some analytical, some algebraic steps. We're going to follow these along, apply to this very first question. Set to 0. I can do that. Let's do it in black. 4 over x minus 2 is less than or equal to 0. Set to 0. Get one fraction common denominator. That's got an x on the bottom. That one needs it. 4 minus 2x all over x is less than or equal to 0. Again, color coding it. Set the numerator equal to 0. That's the root. That's where this graph would cross the x-axis. Subtract 2x, divide by 2. The root is 2. Denominators, restriction, otherwise known as what is the bad domain value? Easy. X equals 0. So I'm going to create a plus-minus line. I don't really have purple, so I'll use green. Now I got to use green for 5. Let's use black again. I have a region of 0. I have a region between 0 and 2. And I have a region to the right of 2. Again, let's pick a number in each region. I'll pick -1, 1, and 3. When I plug it in, I'm going to show you the work a little bit more than I have in the past. 4. I'm going to use this one right here, set to 0. 4 minus 2 times -1, all over -1. -2 times -1 is 2. 4 plus 2 is 6 over -1, also known as -6 is negative. 4 minus 2 times 1 over 1. 4 minus 2 over 1, 2, positive. 4 minus 2 times 3 over 3. 4 minus 6 is -2 over 3, negative. And what regions, what color we got? Red. What regions do I want for less than 0? I want the negative. In other words, x is less than 0 or x is greater than 2. And since it's equal, it's equal, it's equal. But it's not, because you can never include restrictions. It's undefined. Bad domain value. So I'm going to take this out. I think I have to redo it. Include the 2, can't include the 0. So a new question, that is a rational inequality solved analytically. Sorry, I have a bad Smart Notes. That's not a 3, that's a 12 in your example. But we're going to do the same thing. Let's go back to our top. Set to 0, one fraction, numerator to 0, denominator to 0. That gets our partitions. Set to 0. 12 over x minus 3x is greater than 0. When we move that 3x over. Common denominator, x over x. Single fraction. 12 minus 3x squared over x is greater than 0. Root. 12 minus 3x squared equals 0. I'm going to pull out a 3, leaving me with 4 minus x squared, which factors of 2 plus x, 2 minus x, difference of squares. So basic algebra 1. My two partitions are -2 and 2. My two roots. Another restriction, you know, it's another straight ahead one, 0. So I've created a plus-minus line with 3 numbers, therefore 4 partitions. Left of -2, between -2 and 0, between 0 and 2, and right of 2. And we're going to plug into this one right here. And again, we could do the long way, -3, -1, 1, and 3. If I plug -3 into that one right there, 12 minus 3 times -3 squared, all over -3. Let's see what that is. -3 squared is 9. -3 times 9 is -27. 12 minus 27 over -3. That's a negative divided by a negative. What would that be? -15 divided by -3. It's -5. I really just care about the negative. And I'm going to tell you a shortcut. Remember the non-sign changers for absolute values with x's on the right side? There are no non-sign changers for rational inequalities. So I can move forward and change these to plus, minus, and plus. But I'm going to do one more. I'm going to do the 3 all the way over to the right. 12 minus 3 times 3 squared all over 3. 3 times 3 is 9. 9 times 3 is 27. 12 minus 27 is -15. But it's divided by a positive 3 this time. It makes it negative. Oh, I'm sorry. What did I do over here? Negative divided by negative is positive. My bad. I misspoke. That's a plus, that's a minus. I'm terribly sorry. That makes sense because this next region, when they alternate, is negative. That's positive. I could probably throw a positive 1 in there real quick. 12 minus 1 squared minus 3 times 1, my bad. All over 1. 12 minus 3 is 9 divided by 1 is positive 9. It's a plus. So plus, minus, that's our line. And we want pluses. So what is our solution? I can be anything less than -2, or I can be between 0 and 2. I never make them equal with rationals. I go back and look up. It's not equal, so it's just less than to greater than. So there's my solution. A little different, but again, the same strategy, getting that plus minus line. All right, next example. Let's move to this one. We're going to do analytically. Then we're going to go graphically to the other one. Okay? So let's do this. X over x plus 2 minus 3 greater than 0. That makes sense. X over x plus 2 minus 3 x plus 2 over x plus 2. Common denominators. Let's clean this up. X over x plus 2. -3 minus 3 x minus 6 over x plus 2. By distributing through that negative, I change that to a plus. I wanted to make sure the negative got to the x and to the 2. Now we're going to clean that up. X minus 3x is -2x minus 6 all over x plus 2 is greater than or equal to 0. Now we're ready for our root. That graph would cross the x-axis at -3. We're ready for our restriction. It would be undefined at -2. So if I change that to a plus-minus line, it's a very small interval in the middle between -3 and -2. But again, we have that sign change idea. So if I pick the number over here, let's call it -4. -2.5, we'll stay away from that one maybe for a second, unless it's easy, 0. And I'm going to plug into this right here. It's the easiest one. So if I plug -2 times -4 minus 6 all over -4 plus 2. A lot of mental arithmetic. That's a great challenge for you folks. -2 times -4 is 8. 8 minus 6 is 2. -4 plus 2 is -2. That's a -1. Negative. I'm guessing the middle is going to be positive. I'm going to test over to the right with 0. negative 2 times 0. Right? Negative 2, yes. Minus 6, sorry. All over, I could have looked at the left side there. 0 plus 2. Negative 6 over 2 is a negative. And that means this one's a positive. It sure is. What do I want? I want the positives. So I'm going to say the region in the middle here is any number. Not very many solutions between negative 3 and negative 2. It is an equals. But we can never include the restriction of 2. So I'm going to include that, but not that. Now I have a question. I wonder what that would look like graphically. So I'm going to temporarily just get rid of this. I don't want that there. And I'm going to solve this graphically from here. So I'm going to plug that left side into y1. I'm going to plug 0 into y2 so I can use my intersect key. Y equals. Clear and clear. Alpha, y equals. Geez, I do that in algebra all the time. I should forget that. Fraction. X over x plus 2 out minus 3. And I'm going to graph that. Let's just go to zoom 6, get it nice and centered. All right, I'm going to sketch this graph. Does this, and does this. And to turn that 2D graph into a plus minus line, I see three things. I see a region when it's below, a region when it's above, and a region when it's below again. Where does it change? It changes there, and it changes, a little bit offline, at that asymptote. Better on the calculator, right there. Below means minus, above means plus, below means minus. Now, since we've already solved it, we have a pretty good idea of what our root and our restriction are. I'll use the calculator to find the intersection. Forgot to put 0 into y2. I'll use the calculator to find the intersection, which is way over here. I'm guessing it's negative 3. Let's see. Sure is. And the asymptote, I do it this way. Second graph, table, second window. I got to get back to 0 again. Second graph. What's the y value at negative 2? Undefined error. And again, what did I want? I wanted the positives, so I'm just going to choose that one little region in there. X is between negative 3 and negative 2. I can include the root. I cannot include the restriction. Does that graphical answer match with my algebraic answer? 100%. So we just took our graphical approach from the other two and applied it to a rational, and it worked perfectly. Looks like we don't have a whole lot of time left. If we wanted to, maybe what we could do is quickly graph this top one and find it graphically. 8 over x minus 2x less than or equal to 0. Let me pause for a sec. Alpha y equals 8 over x. I don't think I'm going to do it. 15 minutes. I think I'm going to run out. And what do we got? Minus 2x. Well, we got a root and restriction. We got two roots here, an asymptote, and here. So I would obviously have a plus minus, plus minus. we could finish it.